Okay, enthalpy profile diagrams. So first thing to notice about these is what the axes are. The y-axis is always enthalpy, the x-axis is always reaction progress. Okay, you very rarely have any units on these things. So on the left you have the reactants, a line for the reactants, and on the right you have a line for the products. Here I've got R and P. Okay, so this one's an exothermic reaction. So as we saw before, exothermic reactions, delta H is negative. When you label delta H, it's always simply from the line for the reactants to the line of the products. Okay, so in this case it's negative, it's pointing downwards. The actual progress of the reaction doesn't simply go from there to there though, because energy is needed to break bonds first. Okay, that energy is the activation energy. The minimum energy required to start a reaction by the breaking of bonds. Bond breaking is endothermic, it needs energy, so energy has to be put in first. So that activation energy is from the reactants to the top of the graph. So the actual energy we need for this reaction, energy is taken in first before energy is given out. So that's EA, activation energy, the minimum energy required to start the reaction by breaking bonds. Okay, so same thing here on an endothermic reaction. Delta H is positive this time. The arrow is going up from reactants to products, but it's still going from reactants to products. It never goes from products to reactants. And activation energy here, it goes up beyond the products and back down again. So delta H is just from here to here, reactants to products. The activation energy is always from the reactants to the top of the graph. It's always going up, activation energy, because energy needed. If you have a look, the arrow has one arrowhead on it. It's not going up and down like a yo-yo, it's just going up from the reactants to the top of the graph every time. Same axes. So exothermic reactants, products down below, endothermic reactants there, products above. Okay.